Ever wondered why a seemingly calm river can suddenly turn into a raging torrent, causing havoc and destruction in its wake? Floods, one of nature's most powerful phenomena, are more than just an overflow of water. They are complex and multifaceted with various types and causes. Let's start by identifying three major types of floods: river floods, flash floods, and coastal floods. River floods occur when excessive rainfall or snowmelt overflows the banks of a river, while flash floods are sudden and swift, often occurring within 6 hours of heavy rainfall or a dam break. Coastal floods, on the other hand, are driven by storm surges, which happen when high winds and low pressure from storms cause sea levels to rise. Each type of flood is influenced by a variety of factors, including weather patterns, topography, and human activity. As we delve deep into the causes of these floods, we hope to understand how to better predict and manage them. Imagine a river, its banks filled to the brim, suddenly overflowing. This is a river flood. A river flood often occurs due to several factors such as heavy rainfall, rapid snowmelt, and dam failure. When the skies open up and pour down more rain than a river can handle. Or when winter bids goodbye, causing the snow to melt rapidly, the river swells beyond its capacity. And let's not forget the catastrophic effect of a dam failure, where an enormous quantity of water is suddenly unleashed into the river. This influx of water can have devastating consequences. Homes get washed away, crops are destroyed, and unfortunately lives are often lost. The environmental impact is equally severe, with the floodwaters causing erosion and depositing pollutants. Understanding river floods is crucial not just for those living near rivers, but for everyone who relies on these water bodies. Imagine a peaceful street suddenly engulfed by a wall of water. This is a flash flood. A phenomenon as swift as it is destructive, flash floods are the result of a perfect storm of environmental factors. Picture this: torrential rainfall pelting down in a short span of time, especially in areas with poor absorption capacity, such as urban settings or rocky landscapes. The ground, overwhelmed by the deluge, is unable to soak up the water quickly enough. This rapid accumulation of water then rushes into low-lying areas, transforming placid streets into raging rivers in mere minutes. The speed and ferocity of flash floods are what make them so devastating. They can sweep away cars, uproot trees, and even demolish buildings. The force of the rushing water is a testament to the raw power of nature, unchecked and uncontrolled. Flash floods are a stark reminder of how quickly nature can turn. Picture a calm coastal town suddenly inundated by seawater. This is a coastal flood. Coastal floods occur when normally dry, low-lying land is submerged by seawater. They can be caused by a number of factors, including storm surges, high tides, or long-term sea level rise. Storm surges are perhaps the most dramatic. They happen when strong winds from a storm push seawater onto the land, causing a sudden and rapid rise in sea level. High tides can also cause coastal flooding, especially when they coincide with a storm surge. Gradual sea level rise is another culprit. As the Earth's climate warms, sea levels are slowly but surely rising, making coastal areas increasingly vulnerable to flooding. Sadly, coastal floods are becoming more frequent due to climate change. Rising sea levels, more intense storms, and higher tides are all part of this worrying trend. As we grapple with the increasing threat of climate change, understanding and preparing for coastal floods has never been more critical. How do we predict when and where a flood will occur? Well, we have our eyes in the sky to thank for that. Remote sensing and Earth observation satellites. These technological marvels orbit our planet, collecting invaluable data about our world. They help us understand weather patterns, monitor water levels, and even predict the likelihood of floods. These satellites can detect changes in water levels, soil moisture, and precipitation. They also help identify potential flood-prone areas by mapping the topography of the land. This gives us a clear picture of where water is likely to accumulate during heavy rainfall. In the midst of a flood, these satellites become even more critical. They provide real-time images and data of flood-affected areas, aiding in timely and effective relief operations. They show us the extent of flooding, helping rescue teams to prioritize areas that need immediate attention. By harnessing the power of technology, we can better predict floods and mitigate their devastating effects.